Welcome to homework.
So we're looking at the combustion of toluene. So assume we have 20 milliliters of toluene and corresponding density is 0.87 gram per milliliter for toluene. And here is the molecular, the condensed molecular formula. Okay, so part A, what would be the mass of oxygen required for complete combustion? For part B, what would be the number of mole of gaseous powders being produced? And also part C, what would be the number of molecule of water vapor being formed? Okay, so first of all, we have to write out the chemical reaction. So we have C6H5, CH3. You can write it as a normal molecular formula. It's up to you as long as we have everything, all of the atom with the same number, and then we should be good. Okay, so in order to simplify it, because I have showed you the molecular formula, so I will the condensed formula. So I will show you the molecular formula instead. So I just combine all the carbon together and also the hydrogen together. So you will make things easier. Okay, so we have C7, H8, and then we're going to react with oxygen, and then because we are going through a combustion reaction, so we have water, CO2 is a complete combustion. Okay, so we're going to balance the chemical reaction. So we have 7 for carbon, and then we have 4 for water, so we're 8 hydrogens. Okay, so for oxygen, we will have 14 over here, and then we have 4 over here. So total we are 18. So we will need 9 of the oxygen molecule. All right, so yeah, we have the balanced chemical reaction. The next step we are going to do is that we are going to convert all the information that we have in order to find out the actual mass of oxygen that we need. Okay, first of all, we have to find out the mass of the toluene. So we have a 20 mil, and also we will have the density is 0.867. So we are going to multiply the volume and the density of the toluene, and then we will have the mass. So we will have 20 mil multiplied 0.87 gram per mole. Gram per milliliter is the density. And we should be able to find that is equal to 17.34 gram. So we have 17.34 gram of toluene. So how about the number of moles? So we're going to divide the molar mass of toluene, and then we can find the number of moles. So we're 17.34 divided by the molar mass of toluene. So we have 7 carbons, and then we have 8 hydrogen. So at the end, we should be able to find that it's 0.114, should be 115 in order to for subsequent figures to round up. So 115 should be what? Moles. Okay, so this will be the number of moles of our toluene. Okay, how about the number of moles of our hydrogens? From here, we can see that the molar ratio for toluene to oxygen is 1 to 9, 1 to 9. So when we have 0.185, the number of moles of oxygen will be 9 times of that. So it will correspond to 1.696 moles for oxygen. Okay, so we can further convert that to the mass of oxygen. So we just multiply the number of moles by the molar mass. And then we should be able to find it as equals to 54.28 gram. And this will be the mass for oxygen, and this will be for part A. Okay, so part B, we have to find the moles of gas-rich powders. So we have CO2 and H2O. Okay, again, we go back to our combustion reaction equation. So we see that the number of moles of water, the molar ratio of our toluene to water is 1 to 4. 1 to 4. So I'm going to drop down is 1 to 4, and then for carbon will be carbon dioxide will be 1 to 7, 1 to 7. So the number of moles of water will be equals to our number of moles of toluene 0.1885 moles times 4. So you are going to use our calculator 2 times 4, and then we will have 0.754 moles for water. Okay, for carbon dioxide, same thing again. We have the number of moles of toluene times 7. So it's 0.185 times 7. And then we have 1.31 9 moles. Okay, so the total number of moles of gaseous parts will be, we are adding the carbon dioxide and water, so we just need to add these two numbers together, and then we will have the answers. So it will be equals to 2.073 moles. Okay, part C, what would be the number of water vapor, water molecule in water vapor? So we know that the number of moles of water is 0.75 moles. We just need to multiply that by our Avogadro number, and then we will find out the number of molecule. So the Avogadro number is 6.02 times 10 to the power 23, and then we should be able to find that is equal to 4.539 times 10 to the power of 23 molecules of water. And this is the answer for part C.